Welcome you all for today's session. Myself N. Thangavel, Assistant Professor, Department of Information Technology, Tyagaraja College of Engineering, Madurai. In this session, we are going to have a detailed discussion on user and file management. In Linux file security, we have two important management mechanisms. The first one is related to the file access and another one is related to the access rights. In case of file access, we have an authentication mechanism, and in case of access rights, we have authorization mechanism. The two mechanisms has been delivered in the way of user and password authentication and file and directory access control. In case of user in Linux, the Linux assigns a unique ID to each and every user, which will be represented in the term of UID. Each user is a part of at least one group, and each group will also have a unique group ID, which will be represented as GID. Each and every users need to be belong to one among these three type of users. The first one is super user, which is also known as a root user. The user who has full access to all the resources in the system without any restrictions. The super user will be represented with an ID 0. The regular users are considered to be the normal user who have access to their own home directory only. Their user ID will always be greater than 100. We have the third type of user, which is a pseudo user, the account that arrived built into the system and do not reflect real users. So as a user to a Linux machine, we can easily gain a practical experience with this super user as well as through the regular users. So your Linux system supports multiple users who deserves distinct properties and permissions. Linux also defines a group to which a user can belong. So a single user can belong to 16 different groups, but at a time he can belong to only a primary group for a particular access. The primary group of a user is considered to be a owning group on any files or directory that the user creates. So whenever a user creates a file, the file will be belong to a group where a user belongs to a primary group. Let us discuss about the configuration files related to the user management. The first configuration file we are going to discuss about is /etc/passwd. So when we open this file, we will be having multiple entries where each and every entry in a file represents a user account. In this entry, we can find a semicolon, which is a separator for each and every terms. For example, in this particular entry, the first NIR represents the username. We have a separator followed by the X, which represents the password of a particular user. So X is just a block value, where we have another configuration called /etc/shadow, where we can find the encrypted password of the particular user NIR. Then followed by we have user ID, then primary group ID, command session, home directory of a particular user, and a command to execute upon user login. So let us have an in-depth discussion about /etc/shadow file. In this file, we have an entry which belongs to the user test, for example. So here this is an username, followed by we have some set of random symbols which represents the encrypted password. Followed by we have 6 terms. The first one will be the last password change, which will be a date. Next we have minimum number of days we can retain a password, Next thing is the maximum number of days a password to be valid. Then number of days before the password expires, we need to get a warning message to change the password. We can specify the number of days. Then after expiring of the password, if you are not changing the password, so after how much days you can make the account to be disabled. So these are the details which we can see it in your each and every entry of a user in /etc/shadow file. Next, at the last, we have /etc/group file. In this file, we can file the entries for each and every group. In this example, we can see test is a group name, followed by the password, then followed by the group ID, then followed by you can give some list of members. And please have a concern here that we have a separator, that is a delimiter, semicolon between each and every terms in this entry. Let's come to the practical perspective. So if we have a user or a group, we need to manage. So in order to manage a users or group, we will be depending on the commands. Here for user management, we have three commands. The first one is user add, next one is user mod, and next one is user del. The user add has been used to create new users. User mod is to change the modifying the existing user properties. User del leads to deleting the existing users. The similar thing which is applicable to your group add, group mod, and group del. In order to modify the password of a particular user, we can use the command called passwd. The basic syntax is passwd space username. So which will be prompting for your existing password. After entering the existing password, you can give the new password, confirm your new password, and set a new password for a particular user. Next, we are going to discuss about something in detail about file management. Each and every file or directory in Linux is owned by a single user and belongs to a single group. So the ownership details are basically assigned during the time the file or directory are created. Let us have some examples here. Actually, your file have 8 attributes. You can see these 8 attributes when you use a command called ls space -l. ls actually is a command, Linux command, which has been used to list the files which is available in the current directory. And -l is an option which is used to give a detailed description of each and every file in a particular directory. Let us assume here ls space -l space reports, where reports is a specific file name we are mentioning with a command. So we'll be getting an output like this. See here, we have some rw and then followed by a number, then root, then some number, date and time, and their file name. So initially we have some rw, which is representing some type of permissions. Then followed we have a number which is representing the link, number of links we create. Then we have a owner, then we have a owner primary group, file size, the date we created, and your file name. Let us have a detailed discussion of this particular permission. So first we have hyphen, right? The hyphen represents it is a file. In case we have D, it represents a directory. In case we have L, it represents the links. Then followed by it we had rw hyphen r hyphen hyphen and r hyphen hyphen in the previous example, right? So actually the first rwx represents for our owner, next rwx represents for a primary group, and next rwx represents to other users. What is this rwx? Which is nothing but the access modes. So r represents read, w represents write, x represents execute. In case of file, the read permission allows you to view the contents of the file. Write permission allows you to change the content of the file. In case of execute, it allows you to execute the file, where the file will be a binary or shell script. The same thing In case of directory, the read permission allows you to view the contents available in the directory. In case of write, which allows to change the directory contents, that is creating or deleting files. And in case of execute, it access to enter the directory. That is, you can change the directory using cd command. Next, how to change the owner of a particular file, how to change the owner group of a particular file. So we have a commands for it, which is chgrp, which has been used to change the group ownership, and we have chown, which is used to change the owner of a particular file. So which is the basic syntax here. And in case I need to change the permission of a particular file, we have a command called chmod. So how to use this chmod command? So we have two methods of usage to use your RWX, that is access modes. That is symbolic mode and octal mode. The octal mode is also known as absolute or numeric mode. Okay, the symbolic mode is nothing but what we have already seen, that is RWX. The absolute mode is nothing but a number 4 to 1. What is this 4 to 1? So here 4 represents read, 2 represents write, and 1 represents X. This is the syntax of your chmod. So chmod is a command followed by some who, operation, permission, and file name. We know what is file name. And what is this who? So we have some variables like A, U, G, O. A represents all, that is user, group, and others. U represents user, G represents group, and O represents others. In case of operation, we have plus, minus, and equals. The plus represent adding a permission, to who, removing a permission, that is hyphen, equals matching the permission. So these are the operations which we can use here. See here in octal mode, we have read for 4, write for 2, execute for 1, as we earlier discussed. Let us take an example here. We have 6, 4, 4. How do we get 6? Which is for a owner. Next we have a group. Next we have others. So 6, 4 plus 2 is 6. If we count 4 plus 1, it is 5. 2 plus 1 is 3. So read and write, when we combine, we will be getting 6. 4, which is directly a read, because 2 plus 1 is 3. So we don't have 4 here. And we have again 4, which is read. Let us take the another example, 7, 7, 7. So 4 plus 2 plus 1 is 7. So RWX, RWX, and RWX. So the default permission that will be created for a file or for a directory. So in case if you are a root user, the default permission for a file while creation will be 644, and in case of directory it will be 755. And in case if you are a normal regular user, then the default permission will be 664, and for a directory it is 775. Let us have a self-assessment. So now I inform you to write and execute a shell script using a switch case for the following scenario. So you need to create some files and directories. You need to create some users, and using a symbolic mode and using a binary mask, you are expected to do the following operations. Hope you have understood the concepts. So by understanding the concepts, you can try to solve this script and you can execute in your Linux terminal. Thank you.